Hi everyone. In today's lesson, we're going to talk more about trinomials. So before I can go into the different types of factoring, I want to recall one more time how we can multiply binomials into a trinomial. Except this time, your two binomials will have two variables. We're going to have an x and a y. So the first thing that we're going to do is look at multiplying them together. You should remember from last video that multiplying two binomials will always result in a trinomial, right? And I'm going to prove that just now. All right, so let's go ahead and multiply these out. So we're going to multiply x times 3x, x times 3x, that gives me 3x squared. X times 4y gives me 4xy, or you could write it yx. And then 5y times 3x is 15xy. And then 5y times 4y is 20. 5 times 4 is 20. Y times y is y squared. Then we can go ahead and combine our like terms. So we have 3x squared plus 19xy plus 20y squared. So that first conclusion, multiplying two binomials together, will always result in a trinomial, right? 1, 2, 3 terms. So what happened? If we multiplied the first together, so the first ones are these x and x's, right? Those are the first terms. When I multiplied those, I got 3x squared. So that gave me the first term of the trinomial. Then what happened when we multiplied the lasts together? So the 5y times the 4y gave me this 20y squared. So when I multiply the lasts together, I should get the last term of the trinomial. And then how did we get this middle term? Well, we got that by multiplying the outers and the inners, so the different colors, right? These are the outers, these are the inners. So when I multiplied the outers and the inners and then added them together right here, then I get the middle term of the trinomial. Okay, so now that we know how multiplying them works, basically what's going to happen is I'm going to give you this trinomial right here. So let's highlight this one. I'm going to give you this trinomial now, and I'm going to ask you to work backwards to the factors. So now notice this trinomial has two variables. It has an x squared, an xy, and a y squared. Still only two different variables, x and y. And I want to get to these factors. Okay, so just like we factored any trinomial in the past, we're always going to use that AC method where we multiply the first and the last. So we're going to go ahead and do that. So my first term is x squared, and I'm going to multiply that by 9y squared. And when I multiply that, I just simply get 9x squared y squared. A little different, but still the same concept. And we want to find the factors that are going to add to this middle term of negative 6xy. So we're going to multiply them and then find the factors that add. So if you want, you can use the factors in the calculator. Remember to do so, you're just going to type into the y equals 9 divided by x and look at the table of values. I'm going to do it just by hand. So when I want to find the factors of 9, I'm going to start with 1. So we have 1 and 9. And then we have 3 and 3. Now, in order to multiply to an x squared, I need an x and an x. And in order to multiply to a y squared, I need a y and a y. So we can go ahead and just do xy now times xy. So xy and xy. So I want to see the pair on this list that adds to a negative 6xy. Well, if I add 1xy plus 9xy, I get 10xy, which is not that. If I add 3xy plus another 3xy, I get 6xy. So it's closer, but I need a negative 6. So I have to remember that in order to multiply to a positive number, I technically could have two negatives. So I'm going to go with writing negative 3xy and negative 3xy. And I think this is the pair that we want because a negative 3xy plus a negative 3xy actually, in fact, adds to this negative 6xy. So just like we did other trinomials, we bring down the first term, we bring down the last term, and we fill the middle with the stuff that adds. So we have a negative 3xy and another negative 3xy. And now we're going to factor by grouping. So just like normal, we're going to group the first two terms, group the second two terms, and bring down the minus sign. So my first set of parentheses, it looks as that I have a GCF of x. So I can go ahead, take out the x, followed by an open parenthesis. And then now I'm going to divide x squared by x, keep the base, and subtract the powers, so it's just x. Now I'm going to divide 3xy by x, so you should see these x's cancel, and I'm left with a negative 3y. Now over here, my second two terms, I have to take out a negative, but it looks like I could divide 3 by 3 and 9, and a y squared. So I'm thinking I can take out a singular y. So I'm going to divide by negative 3y. Now this one may be a little bit harder to see, so feel free to write the division, minus divided by negative 3y, divided by negative 3y. It might be hard for some of you to do it, in your heads. So over here, the negative 3 and the negative 3 are going to cancel, and the y's are going to cancel. So really, the only thing that I have left is this x term. So the x would be left after the division. Now over here, I have 9 divided by a negative 3. So a positive divided by a negative is a negative 3. Then I have y squared divided by y. So I keep the base, y, subtract the powers, 1. I don't have to write that. So now I did what I was supposed to because now with grouping, these are the same term. So that's my GCF. So I can go ahead and pull out the x minus 3y, followed by an open parenthesis. And I'm going to divide this term by this, so I'm just left with x. And then I'm going to divide this whole thing by this, so I'm just left with this negative 3y. So then that is my final answer. All right, I'd actually like to make a comment on the structures of these multivariable trinomials. So the structure should be that this middle term, the exponent is always half of this exponent here. So if I have an x squared, this should be half of the power, which would be x. If this is a y squared, this in here should be half the power, which is y. So that's like a good idea for you to look at so that you can tell whether you can factor it using multivariables. So like, look, this one has an x squared, so this x has to have a power of 1, half the power. This has a y squared, and this y should have a power of 1. So we know the structure of this trinomial is good to go using the AC method once we have those components. We'll talk more about that tomorrow, but let's try another example together. So we're going to multiply the first term and the last term, and that gives me negative 30 x squared y squared. And I need the factors that multiply to that add to a positive 7xy. So again, you can use the calculator to find the factors. I'm just going to write them out. So 1 and 30, 2 and 15, 3 and 10, and 5 and 6. But remember, I need to multiply to an x squared y squared, so I need x times x, and I need y times y. So x times x and y times y. So I can go ahead and add an xy to each one of these. And I'm looking for a pair on this list that is going to add to a 7x. Well, I notice here that it says a negative 30. So I need to make one of them positive and one of them negative. So I'm going to go ahead and just negate all those and see if I find the right factor. So negative 1 plus 30 is just 29. Negative 2 plus 15 is 13. Negative 3 plus 10, oh, that's it. That works. That's 7. Now, if you had switched them and this pair was like, say, a negative 7, then you just have to switch the negative. So just keep that in mind. So this pair actually did work. So now we can go ahead and factor by grouping. So we're going to bring down the first term, the 2x squared. We're going to bring down the negative 15y squared. And we're going to fill the middle with this stuff right here, the negative 3xy and the positive 10xy. And then we're going to factor by grouping. So we're going to take the first two terms, group them together, take the second two terms, group them together, and put the plus sign in the middle. So if you look at these first two terms, I'm thinking the only GCF that I can take out is an x. And then I'm going to divide each term by x. So 2x squared divided by x is nothing other than x. 3xy divided by x, the x's will cancel, is nothing other than negative 3y. Then in my second two terms, out of the 10 and the 15, I believe I can take out a 5. Then I have a y and a y, so I can actually take out a 5y. And then I'm going to do the division. So 10xy divided by 5y. 10 divided by 5 is 2. The y's will cancel, and I'm just left with this x value. So I have 2x. Here I have 15 and 5, or negative 15 and 5, that's negative 3. Y squared divided by y is just y, so negative 3y. Okay, so taking a look here, oh, I see my parentheses aren't the same, so I might have made a mistake somewhere. And you know what? This is actually good for you guys to see, because if you make a mistake at some point, this is a good way to say, oh, so I did something wrong and I see my mistake already. When I do 2x squared divided by x, the x's divide out to x, but I need to divide that too, so I'm missing a 2 there. So if you had that, great job, it should be there, so 2x. So yeah, this is now the same. So I can go ahead and put a 2x minus 3y in parentheses, followed by an open parenthesis. This divided by this is x. This divided by this is just 5y. And then this is my final answer. Okay, so I'd actually like you guys to try number 3 on your own, but before you actually do it, please change, there's actual typo here. This 3y squared, it should be a b, right? Just keep in mind that something like this could never actually be factored, because this a has to have a half an exponent of this, and this b would have to have a half of an exponent of that. So this would either have to be a y and a y, or a b and a b. So keep that clear. It has to be the same variables throughout. So that's not the right problem. Write this one down and then factor this. And then when you're finished, hit resume for the answer. Okay, so this is what you should have done. 7a squared times 3b squared. You multiply those together, and that's 21a squared b squared. And the factors of 21 that added to 10ab was actually 3a b and 7ab. So factor by grouping says I take the 7a squared and bring it down. I take the 3b squared and bring it down. And I fill the middle with the pair that added to the 10ab. So I do plus 3ab and then plus 7ab. Now, your problem when you did this, you could have had the 7ab here and the 3ab here. Either way, you should still arrive at the same answer as I do. So this is actually good to show. So these two, my GCF was A, and I'm left with 7A plus 3B. Here, I took out a GCF of B, and I'm left with 7A plus 3B. And these 7A's and 3B's are the same, so I'm going to go ahead and pull out one more GCF. So 7A plus 3B, and then I'm left with A plus B. So that should have been your final answer. Okay, so I'd like you to try number 4 on your own. There is another typo on this one as well. I'm not winning on this worksheet. So what I'd actually like you to make this middle term be is negative 15. So make it 3b squared minus 15ba, and then minus 7d2a squared. And before you do it, I want to talk about a few things. First thing is I'm looking at these numbers and I'm thinking that they're pretty high. So we haven't done an example like this, but maybe we could take out a GCF. So let's do that first. I think we could take out a 3 out of all the terms. So if I divide each piece by 3, I get b squared minus 5ba minus 24a squared. So if we look at the structure as well, we have a b squared and an a squared. So in the middle, they should have half of the powers, which is 1, right? And since b came first, then b would come first in here. Since a squared came second, then a would come in here. So it looks like this structure is pretty good to go. So go ahead and factor by grouping, and then hit resume when you're ready for the answer. Okay, so multiply the first and the last, and then by doing so, you'll get negative 24 b squared a squared, and the factors that add to the negative 5ba, which is this middle term, was, hold on, just want to write it down, was a 8ba and a 3ba. But in order to add to a negative, it needed to be a negative 8ba and a positive 3ba. So bring down my first term, which is b squared. Bring down my negative 24a squared, which is my last term. And I'm going to fill the middle with the negative 8ba and the positive 3ba. Now, like I stated before, you could have switched these two values, but you should still see that I should get the same answer. So I'm going to go ahead and group the first two, group the second two, and bring down the sign in the middle. My GCF of the first two was a B, and I'm left with B minus 8A. My GCF of the second two was 3A, and I'm left with B minus 8A. The B minus 8A was my common denominator, or my common factor, and I am left with B plus 3A. And then don't forget, your final answer must include this original GCF of 3. So I can go ahead and bring that 3 down, and this is my final answer. All right, that's it for today. If you have any questions, please jot them down, and we'll see you in class tomorrow. Have a good night.